Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 10 until 11 in the morning, and we are in our second week of our 9-week course. So what work do you need to submit? Well, the support questions are practice problems. They are not for marking. They have a little pencil icon and say support questions. So these are ones that you can decide how many to do and which ones, depending on your needs. You know what you know and what you need work on. So you decide for yourself. If you're understanding things, it's totally fine to skip. If you need more help, more problems, let me know and I'm happy to send you more questions. The answers are in the back of your booklet, so please check your work. This helps you understand if you're on the right track or if you are really missing something and you need to be asking for help. I'm here to help. It's really useful if you have checked your answers first because maybe you got them all. The key questions are the ones with the little key icon, and these are the marked questions. So please do all of these questions, showing all of your work, your steps, and your thinking. This way I can know what it is that you know, and if you are struggling with something, there's more information for me to figure out where you're going wrong. So how do you submit your questions for marking? So there's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan your completed work through that device. The Apple devices have a Notes app, which has a scan function, and the Android devices have Google Drive app that has a scan function. These are pretty much point and shoot. It's pretty straightforward. But if you do need some support, on my YouTube channel, there are tech tutorials that help you walk step by step how to do these, how to scan using these apps. So go check it out there if you need help or ask if you need some more support. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop it off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street with a bright red building next to the post office and have a small white mailbox next to our side entrance. The third method is to hand it into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also fax in their work. Just give us a heads up that that's what you're doing so that it doesn't get lost. Just give us a call or send me an email or something, just so that I can know. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. All of our radio Zoom classes are recorded and I upload them shortly after broadcasting, so that you can get notifications if you're friends or subscribe to my channel. There are also short videos on my channel that help with some fundamental concepts. So if you are struggling with something, go there to check it out, as there might be something that can help you that is a better place to start than just doing a general internet search. Math is incredibly visual, so I strongly encourage you to access the videos. Just listening to the audio is only going to give you a very small piece of what it is that I'm explaining, and you're most likely going to get lost in the shuffle. If you can't join me live through Zoom and you don't have access to YouTube, let me know and I'm happy to send you a copy of the recordings so that you still get the full experience and set yourself up for success. So if you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewahsa. Call me at 807-737-1488, extensions 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., but I am willing to connect with you outside those hours if they don't work. You just need to contact me and we can make a plan that works for both of us. All right, today we are wrapping up lesson 4. We did in our last lesson the first part of the Exponent Laws, and now we are continuing with the second part. These ones are a little bit tricky, so you need to understand. All right, we'll set you up for more success if you understand the previous ones. So I strongly encourage you to watch the first part of the Exponent Laws lesson, the other video, which I'll link in the show notes, so that you know what is going on. All right, so our learning goals for today are that you'll be comfortable calculating simple powers and you will understand the logic behind the exponent rules. Our success criteria are that you can execute with comfort the multiplication, division, and power rules, which is what we focused on the previous lesson, and that you can explain the reasoning behind zero and negative exponents, which is what we're going to focus on today. But first, let's activate our brains with some mental math. I don't believe in Mad Math minutes. They cause stress and anxiety in students and focus on memorization and speed, which are not essential tools for being successful in math. So instead, we work on developing skills that are transferable and are based on comfort and confidence in yourself. So really, we're giving the tools that you might be able to use in your own life. We are going to be doing our question is 63 divided by 4, and we're using the strategy of multiplying up. So this strategy is, instead of, we're thinking about what groups, how many groups are going to get us to 63, how many groups of 4 are going to get us to 63. So I'm going to say, okay, well, I know that 4 times 10 is equal to 40. So I know that it's going to have to be bigger than 10. But if I do 4 times 20, that's going to be 80. So it's going to be smaller than, I'm going to be doing less than 20 groups. So let's do halfway between 4 times 10 and 4 times 20. So 4 times 15. Well, halfway between 40 and 80 is 60. Okay, so now I'm actually, pretty close to 63. So let's say if I do 4 times 16, that's just one more group of 4. So that's going to give 64. And now I'm over 63. So that means that 4 times 15, which gives me 60, means that I'm going to have a remainder of 3. I can't get another group of 4. So 63 divided by 4 is 15 with a remainder of 3. Or you could say, well, if I have a remainder of 3 out of 4, that's going to be 15.75. If that is something that comes naturally to you, great, because 3/4 is 75 cents, or like 3/4 is 75 cents, or 0.75. So if that clicks for you, great. If you just need to leave it as a remainder, that's fine. But thinking of these friendly groups got us pretty quickly to our answer. So before we dive into our new concepts today, let's just remember some prior learning. So just some exponent reminders. The base of our exponent is the number at the bottom, the big number at the bottom. The exponent is the little number that is like shifted up to the right, and the whole thing is called the power. Remember, the exponent states how many times the base value is being multiplied by itself. So for example, if we have 5 as our base, 5 as our exponent, then we're doing our base times our base times our base times our base times our base. Then let's just quickly remember what the exponent laws are from part 1. Again, if you haven't watched part 1, I strongly encourage you to go do that. If you just need a little bit of a refresher, this is just a little itty bitty refresher. So first we need to have the same base, and the multiplying powers rule means that when we're multiplying powers with the same base, then we add the exponents. When we are dividing powers with the same base, we subtract the exponents. And when we are doing a power of a power, means that we multiply the exponents. So those are the tools that we have already. So let's dive into our new learning today, which is definitely a bit of a tricky one. So first, we're going to look at when 0 is our exponent. And we're going to do this in two methods to really help you understand the goal of this. The rule is not super intensive, like there's not a lot of parts to the rule, but understanding why the rule makes sense and therefore accurately following through with the rule can be really challenging. Lots of people make mistakes with this, even though the rule is fairly straightforward. People still make mistakes with this all of the time. So first we're going to do it with two methods, and first we're going to look at the pattern to see if we can understand what the 0 as the exponent rule makes it, how it works. So we're going to use the example of y equals 2 to the exponent x. So here's key that our exponent is where our variable is. That's the part that we're changing. So looking at a table of values, when x is 5, that means we have 2 to the exponent 5, which is equal to 2 times 2 times 2 times 2 times 2, which is equal to 32. Okay, so when x is 4, then we have 2 to the exponent 4. So that's 2 times 2 times 2 times 2, which is equal to 16. When x is 3, we have 2 to the exponent 3, which is equal to 2 times 2 times 2, which equals 8. When x is 2, we have 2 to the exponent 2, so 2 times 2, which equals 4. And when x is equal to 1, we have 2 to the exponent 1, which is equal to 2, which is equal to 2. So as you can see, these are all, we are just decreasing one unit in our value for x to see what happens. We're getting closer and closer to 0, where our x is equal to 0, which is our exponent, to see what might happen. Because really, it doesn't, if we're going x to the exponent 0, or sorry, 2 to the exponent 0, because x is equal to 2. X is equal to 0, my apologies. We can't, like, how many 2's times itself is that? That doesn't, we can't use that same idea because we don't have any 2's. So does that just mean that we don't have anything? What? This doesn't make any sense. So what we're going to do is that we're going to look at the pattern. So when we increase x, our exponent value, we are multiplying by one more 2. Our constant ratio is 2, right? We're increasing. The x is telling us how many 2's to multiply by, so we're always multiplying by 2, one more 2 as our x's get bigger. So that means that if we're following the pattern, if we get our x's to be smaller, if we divide by the previous term by 2, which is our constant ratio, then we're going to find the next term in this pattern. So 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So in theory, if we divide by 2, just like we have been doing, we're going to get our next term. So if we do 2 divided by 2, we get 1. So that means that 2 to the exponent 0 is equal to 1, because every previous term divided by 2 gets us our next term. So 2 divided by 2 is equal to 1. So our rule is that, so we can see that 2 to the exponent 0 is equal to 1. Okay, so that's our first introduction of what we have. 0 as our exponent, we have an answer. But how does that help us for other questions other than just this one? So let's use another base. Let's see if we change the base, does that change anything? We did a base of 2. Now if we have a different base, what's going to happen? So we're going to use y equals 5 to the exponent x. Again, using a table of values, looking at the pattern. So if x is equal to 3, that means that 5 to the exponent 3 is 5 times 5 times 5, which is 125. X to the exponent 2 is 5 to the exponent 2. Sorry, x equals 2 is 5 to the exponent 2, which is 5 times 5, which is 25. X to the exponent 1, I'm doing the game. X equals 1 is 5 to the exponent 1, which is equal to 5. And again, we're at 0, so 5 to the exponent 0 is going to equal what? So still the same things happening, right? When we're increasing our x value, we're multiplying by one more 5. So our constant ratio is 5. We're always multiplying by 5, which means that if we're going opposite direction, if we divide the previous term by 5, we will find the next term, right? 125 divided by 5 gives us 5. 25 divided by 5 gives us 5. So 5 divided by 5 gives us 1. So again, x is equal to 0. So that means that y is 5 to the exponent 0 equals to 1. So we've got the same thing. So last time we had 2 to the exponent 0 equals 1, and now we have 5 to the exponent 0 equals 1. So we maybe are seeing a pattern emerging. So let's do this in general. Let's just do it with a b for our base. We don't have a number there. That's not going to matter. We can put anything in for b. So we're just going to do b as a general term. So with our table of values, if x is equal to 5, that means that y is equal to b to the exponent 5. So that's b times b times b times b times b, which is b to the 5. If x is 4, we have b to the 4, which is b times b times b times b, which is b to the 4th. X is equals 3, so b to the cubed is b times b times b, b cubed. X equals 2, so we have b squared, b times b, it's b squared. X to the equals 1, we have b to the 1, which is just b. So we're back to 0, x equals 0, so we have b to the exponent 0. So what, does it still make sense? Well, yes, we've increased our x value. We're multiplying by one more b, which is our base. So our constant ratio is b. And this time we don't have an actual number, but we just have b as our base. It doesn't matter what the value is. So again, if we divide our previous term by b, we'll find the next term. So b to the 5th divided by b, well, it means we're canceling off 1b, means that we only have b to the 4th. B to the 4th divided by b is equal to b to the 3rd. B to the 3rd divided by b is b squared. B squared divided by b is equal to b to the 1, just b. Okay, so then to figure out our b to the 0, so b divided by b is equal to 1, right? The base is the same. We're dividing it by itself, means that it's going to always equal 1 no matter what that number is. So b to the exponent 0 is going to equal 1. So always, every time b to the exponent 0, any base to the exponent 0 is always going to equal 1. Because of this pattern that we can see, is that we always end up like we're dividing it by itself. So that always equals 1. All right, so that's the first method of trying to understand 0 as the exponent. The second method, we're going to look at division. So we're going to use the division law that we have been, that we looked at in our last session. And this is how your booklet does it. So this looks a little bit on page 27. It looks into this a little bit. I find that it doesn't go into as much detail as I would like. So hopefully this is helpful. So we're going to use the example of 7 squared divided by 7 squared. Remember, it doesn't matter how we write it. This is just how I like writing it in the fraction. Helps my brain. So 7 squared divided by 7 squared is equal to 7 times 7 divided by 7 times 7. Same thing on the top as the bottom, which means that we can cancel those 7s off, right? If we're multiplying something by 7, then dividing by 7, that cancels off. We haven't changed it. It's just like we're multiplying by 1. And here we're doing it twice. So really, we're just left with 1 over 1 which we can simplify to just be 1. So if we, which makes sense, because anything time we divide by ourselves, the same thing, we end up with 1. Okay, so that hopefully makes sense. But if we go back to our shortcut into our division rule, remember our division rule is that when we're dividing with numbers with the same base, we subtract our exponents. So 7 squared divided by 7 squared is equal to 7 to the exponent 2 take away 2. Well, 2 take away 2 is 0. So 7 to the exponent 0 is the same thing. This, if we use the division rule, we know that we can simplify this to 7 to the exponent 0. Well, that means that 7 to the exponent 0 is equal to 1, because both of these things, we've done the same thing in just 2 different ways, but we look to see that they are equivalent, they're the same thing. So again, we can see that a base to the exponent 0 is equal to 1. So let's look at it with variables to see, to make sure that it's not just about the 7. So we have t to the exponent 8 divided by t to the exponent 8. So this is t times 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 t divided by t times 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 t, right? 8 t's on the top, 8 t's on the bottom. So again, we can cancel them off because we're multiplying by t and then dividing by t. That doesn't change. So we do it as many times as we can do it. We cancel them off. And because we have the same number of t's on the top as the t's on the bottom, they all cancel off and we're just left with 1 over 1, which is equal to 1. So if we look at our shortcut, t to the exponent 8 divided by t to the exponent 8 is equal to t to the exponent 8 minus 8, because we're dividing, so we subtract our exponents. So again, 8 minus 8 is 0. So we have t to the exponent 0. So again, we can see that it doesn't matter what our base is. It doesn't matter what the number is that we're doing by multiplying by itself. Anytime that we have a base to the exponent 0, it's equal to 1. The answer is equal to 1. And that is our zero exponent rule, is that anything with an exponent of 0 equals 1. Doesn't matter if it's a million, a billion, a super long decimal, a really awkward fraction. Anything raised to the power 0, to the exponent 0, is going to equal 1. The only exception is 0 to the exponent 0. That can't be solved. That doesn't make any sense, because we can't, if we think about, we ended up having like the division rule, we would have 0 divided by 0, and we're not allowed to divide by 0. The world implodes if we divide by 0, right? Because it doesn't make any sense to put any number of things into a group of 0 or into 0 groups. So the 0 to the exponent 0 cannot be solved. It doesn't exist. But everything else, all the other awkward numbers to the exponent 0 is going to equal to 1. Okay, so let's do some practice, because you probably aren't going to believe me. So you can do this on your calculator. So we can actually see. So 25 to the exponent 0. So let's go to our calculator and see if I'm making things up. So 25 to the exponent 0. So remember, our exponent button is this a to the exponent b on Desmos. So 25 to the exponent 0 is equal to 1. Okay, I wasn't lying. Okay, what about if we have a negative? So we have negative 3,726 to the exponent 0 is equal to 1. Okay, here I've got 1 million to the exponent 0. Then let's times it by 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see I just put in numbers so that you can see to the exponent 0 is equal to 1, because both of these things equal 1. So 1 times 1 is equal to 1. So again, anything to the exponent 0 is always going to equal 1. Take some practice, put in your calculator till you believe me. Even here, we have variables. We can't put these into our calculator to see. But if I have any base p to the exponent 0, it's going to equal 1. If I have negative q, negative any negative number to the exponent 0 is going to equal 1. Here I have s to the exponent 7 times s to the exponent 3 divided by s to the exponent 10. Okay, so they all have same bases. So let's use our rules from before. because we don't have any zeros. So let's use our multiplication division rules. So we have s to the exponent 7 plus 3 because we're multiplying, and then minus 10 because we're dividing. So s to the 7 plus 3 is 10. Oh, 10 take away 10 is 0. So s to the exponent 0, that is going to be 1. So sometimes you don't see a 0 initially, but as you work through it, you end up with a 0 exponent, and so then that still equals 1. Okay, so now that is the 0 exponent rule. Now let's look at negative numbers in your exponent, which also is weird. So we're going to again do this in the two methods. We're going to look at the pattern, and then we're going to look at some division to see how it makes sense in order for you to be able to use the rule, because that simplifies your life. But let's understand why the rule works. So again, we're going to use the pattern method, and we're going to use the example y equals 3x. So using our table of value, x equals 3, y equals 3 to the exponent 3, which is 3 times 3 times 3, which is 27. X equals 2, so 3 squared is 3 times 3, which equals 9. X to the exponent 1, which is 3 to the exponent 1, which is 3, which is just equal to 3. X equals 0, so we have 3 to the exponent 0. So we know that now this equals 1 from what we've just learned. 3 to the exponent 0 equals 1. Okay, but what if we have negative 1 now? We're continuing this pattern on where our x values are getting lower and lower. So 3 to the exponent negative 1, what is that going to be? Well, we can do the same thing that we did before, is that we know that our x values, when we increase them by 1, we're increasing by 1 more 3, which means our constant ratio is 3. We're multiplying by 3 every time. So we can divide our previous term by 3 and we'll find the next term. So we can keep doing the same pattern that we did before, but now we're going to go past 0. So 27 divided by 3 is equal to 9. 9 divided by 3 is equal to 3. 3 divided by 3 is equal to 1. And so now we keep going. Well, 1 divided by 3, right, because we're still dividing by our constant ratio of 3. Well, that's 1 over 3, because 1 divided by 3 is 1 divided by 3. And we still have, we're just dividing by 1, 3, right? We have our exponent. It's like we can have an exponent of 1 on our 3, because every time we have just a 3, we have an invisible exponent of 1 that mathematicians are too lazy to write. So when x is equal to negative 1, when that means that we have 3 to the exponent negative 1, this really is 1 over 3 to the exponent 1. Okay, so let's see, well, what if we have x to the exponent, sorry, x equals negative 2. So 3 to the exponent negative 2, we keep going. So that means that we're going to divide our previous term by 3. So we have 1 over 3 divided by 3. Well, that means that we have 1 over 3 divided by 3 times 3, because we're dividing 1/3 by 3. So that's 1 over 3 squared. So we have 3 to the exponent negative 2 is equal to 1 over 3 to the exponent 2. Okay, let's do it one more time. So x equals negative 3 now. 3 to the exponent negative 3. So we're going to divide our previous term by 3. So 1 over 3 squared divided by 3 is equal to 1 over 3 times 3 times 3. So that is 1 over 3 cubed, 3 to the 3. So 3 to the exponent negative 3 is equal to 1 over 3 to the exponent 3. So what this means is that so 3 to the exponent negative x, so if negative x is in our exponent, then this is equal to 1 over 3 to the exponent positive x. So we end up with a fraction. We end up with 1 over what our base is, and our exponent now goes from being negative to being positive. I know, it's weird. Let's do another example to help it to just keep looking at it. So we're going to use y equals 6 to the exponent x. So if we have 5 as our x, so y to the exponent, sorry, y equals 6 to the exponent 5. So that means we have 6 times 6 times 6 times 6 times 6, which is 7,776. If x equals 4, 6 to the 4th is equal to 6 times 6 times 6 times 6, which is equal to 1,296. X is equal to 3, 6 the exponent 3 equals 6 times 6 times 6, which is 216. X equals 2, so 6 squared is 6 times 6, which is 36. X equals 1, 6 to the exponent 1 is just 6, so it's just 6. X equals 0, so 6 to the exponent 0 is equal to 1, right? Anything to the exponent 0 is equal to 1. So now we're in our negatives, so x equals -1, so that means that we have 6 to the exponent -1. But remember, see, we have a constant ratio of 6. As we increase our x values, we're multiplying by 1 more 6. So that means that we can still divide our previous term by 6 to find the next term. So 7,776 divided by 6 is equal to 1,296. 1,296 divided by 6 is equal to 216. 216 divided by 6 is equal to 36. 36 divided by 6 is equal to 6. 6 divided by 6 is equal to 1. Okay, so now we're in this. We've gone through all the ones that make sense. So now we have 1 divided by 6. Well, again, that's 1 over 6, right? We don't have, we're just doing 1 divided by 6. So 1 over 6 is equal to 1 over 6 to the exponent 1. That 1 shows up again. So if we do -2 as our x, 6 to the exponent -2, we're going to divide 1 over 6 to the exponent 1 by 6, which means we have 1 over 6 times 6, which is equal to 1 over 6 squared. So 6 to the exponent -2 is equal to 1 over 6 squared. 6 to the -3, if x is -3, we divide 1 over 6 squared divided by 6 is 1 over 6 times 6 times 6, which is equal to 1 over 6 cubed. Which means that 6 to the exponent -3 is 1 over 6 cubed. Keep going. -4, 6 to the -4. Divide again. We have 1 over 6 cubed divided by 6 is equal to 1 divided by 6 times 6 times 6 times 6, which is 1 over 6 to the 4th. So 6 to the -4 is equal to 1 divided by 6 to the 4th. So again, 6 to the -x, 6 to any negative exponent is equal to 1 divided by 6 to the positive exponents, to positive x, to the same number, but now it's positive instead of negative in your exponent. Okay, so let's look at it just in general. If we have a variable for our base. So we have y equals b to the exponent x. So again, 3 is our x, b to the 3 is b times b times b, which is b cubed. X equals 2, b squared is b times b, b squared. X is 1, we have b to the 1, which is b to the 1. X is 0, we have b to the 0 is equal to 1. We know from what we've done before. So we want to keep going into x's are negatives. Well, this time we have a constant ratio of b, right? We're multiplying by b every time as our x's increase. We're getting 1 more b. So that means that we can divide by b and we will find the next term. So b cubed divided by b is b squared. B squared divided by b is b. B divided by b is equal to 1. So 1 divided by b is 1 over b, which is the same as 1 over b to the exponent 1. So if x is -2, we have b to the -2. So 1 over b divided by b is going to be 1 over b times b, which is equal to 1 over b squared, which is equal to 1 over b squared. B to the exponent -2 is equal to 1 over b to the exponent +2. We have x is equal to -3, b to the -3. We do 1 over b squared divided by b, which is equal to 1 over b times b times b, which is equal to 1 over b cubed. So b to the exponent -3 is equal to 1 over b to the exponent +3. So it doesn't matter what the base is. So b to the exponent -x is equal to 1 over b x to the exponent x, where we have positive x, right? We still have the same number, but it's now positive instead of negative. Okay, so let's look at the same concept, negative numbers as your exponent, but let's use division as our second method in case this way makes more sense to you. And this again is on page 27 of your IL booklet. Again, a short example to show you what it is. So we're going to use the example of 4 to the exponent 3 divided by 4 to the exponent 9. So 4 to the exponent 3 divided by 4 to the exponent 9 is the same as 4 times 4 times 4 divided by 4 times 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 4. So again, we're going to cancel them off, right? So because we're multiplying something by 4, we can divide by 4. But this time we can't cancel them all off because we don't have the same number on top as on bottom. So we're able to do it 3 times because we have 3 4s on top. We also have 3 4s on the bottom. So we're multiplying by 4 3 times on the top and multiplying by 4 3 times on the bottom, so we can cancel them off. So that means we end up with 1 over 4 times 4 times 4 times 4 times 4 times 4. Okay. So that's 1 over 4 to the exponent 6. We now have 6 4s on the bottom. Okay, that makes sense. But let's look at the shortcut. So with the shortcut, we have 4 to the exponent 3 divided by 4 to the exponent 9. Well, we're dividing, so that means that we subtract our exponents, right? So we have 4 to the exponent 3 take away 9. Well, 3 take away 9 is -6, right? If we are at 3 degrees and we go down 9 degrees, we're going to end up at -6 degrees. So 4 to the exponent 3 divided by 4 to the exponent 9 is equal to 4 to the exponent -6. Well, if we take these two parts, we have 4 to the exponent -6 is equal to 1 over 4 to the exponent +6. And that's another way of understanding it. Let's look at an example with a variable. So we have w to the exponent 4 divided by w to the exponent 6. So that means we have w times w times w times w divided by w times w times w times w times w times w. And we cancel off those w's. So we do it 1 on the top, 1 on the bottom, 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 right? And they cancel off. So we only do it until we run out of w's on either the top or the bottom. And then we have to stop because we don't have any more to cancel. So we're left with 1 over w times w, which is the same as 1 over w squared. Okay, so let's look at a shortcut. W to the exponent 4 divided by w to the exponent 6. We're dividing, so we subtract our exponents. W to the exponent 4 take away 6 is equal to w to the exponent -2. So w to the exponent -2 is equal to 1 over w to the exponent +2. So again, our base doesn't matter, it doesn't change it. If we have a negative exponent, we end up with 1 over the base with a positive exponent. So that is our negative exponent rule. The rule is a negative exponent equals the reciprocal of the base. Reciprocal means 1 over. So it's 1 over the base with a positive exponent. That's what the rule, what it actually plays out to be, what it means. Okay, so let's look at some tricky examples, because sometimes they like to just make things a little bit harder just because. So what if I have my negative exponent in the denominator in the bottom of my fraction? So for example, I have 1 over 2 to the exponent negative 10. So here, what happens is a reciprocal means that we flip it. And so we flip our fraction, which means that what is on the bottom goes to the top and what is on the top goes onto the bottom. So we have 2 to the exponent 10, because once we flip our fraction, we get a positive exponent divided by 1. Well, 2 to the exponent 10 divided by 1 is just 2 to the exponent 10. So again, if we have, for another tricky example, we have 7 over 8 to the exponent negative 4. Well, here I don't have a 1. So what do? Well, again, reciprocal of a fraction means that we flip what's on the bottom to the top and what's on the top to the bottom. So we have, oh, right, sorry. First, I'm going to apply when I have a fraction, I can apply that negative exponent to both my numerator and my denominator. That's how it works, right? So I have 7 to the exponent negative 4 divided by 8 to the exponent negative 4. So when I'm flipping my reciprocal, I now have 8 to the exponent positive 4 divided by 7 to the exponent positive 4. Okay, I know they're tricky. This one take a lot of practice. So let's do some practice. So here this says evaluate. So it wants us to get a number, but we're going to follow the steps in between to see how we got there. So we have 4 to the exponent negative 3. So that means that I have a negative exponent. So I'm going to have 1 over 4 to the exponent positive 3. Well, 4 to the exponent positive 3, 4 times 4 is 16, times 4 is 64. So I end up with 1 over 64. If I have negative 8 to the exponent negative 4, so I'm going to have 1 over negative 8 to the exponent positive 4. Well, negative 8 times negative 8 is positive 64, times negative 8 is, I don't know. So let's use our calculator to see what happens. So let's just do, if we are trying to do the calculations. So I'm going to do negative 8 to the exponent 4 is 4,096. So this is going to end up with 1 over 4,096. But let's look to see if we were just to put your whole thing in. So if I did negative 8 to the exponent negative 4, well, I get this not very nice decimal, but remember in decimals we can convert to a fraction, and look, we get 1 over 4,096. That's what we wanted. So sometimes if you use your calculator and you get this not very nice fraction, it's because our decimal, it's because it's a very small fraction. And so then you want to think about, you want to not just do the whole thing, you want to think about, well, what's your denominator going to be? Okay, so then I have 3 to the over 4 to the exponent negative 2. So I'm going to have 3 to the negative 2 over 4 to the negative 2. Well, that means that both of these I'm going to swap, right? I'm going to do the reciprocal. So I'm going to have 4 squared over 3 squared which is going to equal to, well, 4 squared is 16, and 3 squared is 9, and I don't have any comments, so I'm just going to leave it at that. So that's how I can evaluate them. If it says to simplify, then our simplify means positive exponents. I'm just spelling things wrong. Ugh, anyway. Okay, so d to the exponent negative 10 means 1 over d to the exponent 10. And that's all we need to do. Negative e to the exponent negative 3. Here I have two negatives, but they mean different things. So that means that I have 1 over negative e. That is still my base to the exponent positive 3. So this negative e doesn't become positive. That's still my number. That's my base. My base doesn't change. It's just that now I have the reciprocal of my base. I have 1 over my base with a positive exponent. Okay, here I have j to the exponent 6 divided by j to the exponent negative 2 times j to the exponent negative 5. Okay, so I'm going to have j to the exponent 6. I'm dividing, so take away negative 2, and then I'm multiplying. So I add negative 5. So I end up with j to the exponent 8 plus negative 5. So I end up with j to the exponent 3 because 8 take away 5, 8 plus negative 5 is 3. So sometimes you can have weird, awkward negative things and still end up with a positive. So you just got to be really careful about those negatives and what they mean. So now you can do the support questions on page 28. Remember how you can do all the support questions on page 28 because of the ones that we did before for the first part of lesson 4. But questions 1A, C through G, and 2A through C, E, and F all use both or either zero exponents or negative exponents. So you need these tools today in order to do now all the support questions, as well as the tools that we used from last time. All right, let's do a few practice questions. Again, what is the question asking? So evaluate means that you should calculate to a final answer. You should have a final number. Simplify means that you combine your exponents as much as possible and you have no negative exponents. You only have positive exponents. That's what simplify means. Okay, so simplify the following. Let's look at these questions. We have 4 to the exponent 12 times 4 to the exponent negative 3 divided by 4 to the exponent negative 9. Order of operations still matters. So we still need to follow those rules that we do from left to right when we have multiplication and division. So this is equal to 4 to the exponent 12. Well, we're multiplying bases the same, so we're going to add, but we have a negative, so we're going to add a negative, and then we're going to subtract because we're dividing, and we're going to subtract a negative. Again, you can do this in multiple steps if you need to, whatever makes the most sense for you. 12 plus negative 3 is going to be 9. Minus negative 9 is going to be positive 18 because 9 plus 9 minus negative 9 is positive 18. If adding and subtracting integers, not negative numbers, is confusing and hard for you, totally understandable. Lots of people make mistakes. Go check out my YouTube channel. There are some videos there that I've gone through about that help you practice and talks you through integer arithmetic. Okay, part B, we have another one. These ones can look really confusing and ugly, so breathe. So here we have 9 to the exponent 9 divided by 9 to the exponent 4 divided by 9 to the exponent negative 2 divided by 9 to the exponent 0, all times 1 over 9 to the exponent negative 3, all to the exponent 6. These are meant to be confusing. They're just meant, they're not practical or necessarily useful, but they're like problem solving. They're like riddles, which is why. So just breathe through them, go through step by step. So I'm going to do, first I'm going to simplify because I already have like these fraction divisions. I'm going to simplify those first, and then I'm going to go from there. So inside my brackets. So I have 9 to the exponent 9 divided by 9 to the exponent 4. So I'm going to do 9 to the exponent 9 take away 4. And then I'm going to divide by 9 to the exponent negative 2 take away 0. Okay. And then times, well, 1 over 9 to the exponent negative 3. Well, that's 9 to the exponent positive 3, right? Because I 1 over 9 to the exponent negative 3, I do the reciprocal, so I have 9 to the exponent 3. Okay. So 9 to the exponent 9 take away 4 is 9 to the exponent 5. Divided by 9 to the exponent negative 2 minus 0. Well, that's 9 to the exponent negative 2. Times 9 to the exponent 3, all to the exponent 3 is 9 to the exponent 3 times 6. So now I have 9 to the exponent 5 take away negative 2 because I'm taking away, but I have a negative exponent. I'm dividing, but I have a negative exponent. And then times, so I'm adding, and 3 times 6 is 18. So 9 to the exponent 5 take away negative 2 is 7 plus 18 is 25. So again, think about it like it's a riddle. Think about it like it's a logical puzzle. It's sure not necessarily useful in terms of day-to-day use of exponents, but manipulating them helps you understand so that you can apply it in other situations where it might be useful. Okay, I'm just trying to look to see which one. I'm gonna skip C. It's ugly and gross, but you can do it. Just remember, collect your like bases and make it work based on the bases that are the same. But I'm going to do this D because we didn't do one like this in the last lesson. So we have 5 to the exponent A divided by 5 to the exponent B times 5 to the exponent A. So here we have our exponents have variables. So then we just we combine the variables as much as we can. So we have 5 to the exponent A plus B, right? Because we have, sorry, not plus B, minus B. We're dividing. See, mistakes happen all the time. That's why it's good to check to make sure that what you're saying makes sense. 5 to the exponent A minus B, because we're doing 5 to the exponent A divided by 5 to the exponent B. Then times 5 to the exponent A, so plus A. So then this equals 5 to the exponent 2A minus B. And that's as far as we can simplify. We can't simplify any further. We don't have any more information. That's as far as we can go. All right, so another way to say it is expressed as a single power. It's the same idea. Again, follow the steps, simplify what you can, and give yourself lots of steps if that's what you need. So let's consolidate what we've learned today. So we're going to consolidate all of lesson 4. So remember, for same base, we have our multiplying powers rule. We add our exponents. When we're dividing our powers rule, we subtract our exponents. When we have our powers to our power rule, we multiply the exponents. So this is that you can execute with comfort, hopefully, the multiplication, division, and power rules. And then new today, the exponent rule is that anything with an exponent of 0 equals 1. It doesn't matter what the base is unless it's 0. Remember, 0 to the exponent 0 doesn't exist. And the negative exponent rule is that a negative exponent equals the reciprocal of the power. So 1 over the base with a positive exponent. So if you just have a whole number that doesn't have a fraction, then that is equal to 1 over that, because remember, any number is always over 1. We always can say that it's over 1. So then the reciprocal is going to flip it. Then, or if you do have a fraction, then you flip it, the denominator goes to the numerator goes to the denominator, and you end up with a positive exponent. You always end up with a positive exponent when you are, after you do the reciprocal of something with a negative exponent. So now hopefully you can explain the reasoning behind the 0 and negative exponent rules and apply these rules. I know they are tricky, they take practice. So let me know. Let's chat about them if you need practice, if you need help. So on that note, if you do need support or help, give me a call at 807-737-1488 or toll free 1-800-667-3703. My email address is bronwyn.slate@nnec.on.ca. Connect with me through Facebook at bslatewasa or on YouTube. Remember, this lesson, as well as some of the other support things, are up on our playlist, which is MBF3C at bslatewasa. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.